The engineering design process. Let's look at the steps involved in an engineering design process. And there's different definitions and different ways we can break up these steps. We'll take a look at a couple of them and look at our example. ABET has a definition of a number of steps, from determining objectives and criteria, coming up with ideas through an engineering synthesis, doing an analysis on that to determine which is best, building it and testing it, and then evaluating as the best design in the end. That's an example of a stepped process through engineering. NASA has another definition which has some similar steps. There's some overlap in these. This happens to have 8 steps instead of the 7 previously. Oakes, the textbook, has 10 steps. There's identifying the problem, looking up criteria and goals, and determining what we're going to try to achieve. We need to do some research, some brainstorming. We can analyze solutions, develop some models or maybe some prototypes, make some decisions along the way, communicate those decisions to a team or someone that's going to be making it in order to implement it, and make sure that we've achieved our functions in the end. So that's kind of a longer process. We're going to take a simpler process. We'll go through 5 steps, which kind of encompasses some of those more in kind of a general. So let's look at defining the problem. First thing we're going to have to do when we're defining a problem is determine what are the customer needs. We have to identify who's going to be using this product. And there could be layers of users. There could be someone actually using it. There could be someone else that could be maybe selecting it out, picking out what product we're going to purchase. There could be someone else that's going to be paying for it. So we have to determine who is actually we're trying to meet the needs of, and determining which customer we're trying to meet. And then what do they actually want? What do they need in this product? So we can maybe do some discussion with them, do some research. We need to try to determine what's the most important things we're trying to achieve. And then we try to identify the exact problem we're trying to solve. So we want to have a clear, concise problem statement. If we can write it in 10 words or less, that's a good goal to have. It should come out of our process of going through our customer needs analysis, that we're going to be determining what does the customer actually need, and that's going to determine our problem statement. So how are we going to measure our goals and our criteria? We have to determine that. We have to determine what is the objectives, what is the first objective we're trying to meet. There could be other objectives, and we can rank those in order to determine which is the most important. And there could be other obstacles, other things that we have to, constraints that we have to consider when we're designing it to make sure that we're going to make a good design in the end. Some of these things may be challenging to try to solve. So we have to identify the problem and set up some of these criteria at the beginning. So then we want to try to develop some design specifications. So these are our goals and our constraints that are going to be maybe written in more engineering terms to determine how we're going to achieve our goals, what types of metrics can we use in order to know that we're meeting that goal or that constraint. We could look at, there's lots of functional types of constraints, and ABET also has a list of constraints that maybe are outside of the normal list of constraints, such as economic factors. We have safety issues, reliability, is this thing going to be useful? How does it look? How does the user interact with it? What is it? Is there any impact on the society that it's being used in? Are there any ethical considerations along the way? So those are some additional constraints we may need to consider when we're designing our product. Then we can go on to a concept generation stage where we're trying to come up with ideas, we're doing our brainstorming, we're trying to determine what functions does our product need to do. We can break that down into smaller steps and try to figure out ways we can achieve those sub-functions. There's different methods to come up with ideas in order to achieve those. And then we may need to use our constraints that we have in order to rule out some off-the-wall ideas. And then we can also update our specs. You'll see we'll actually can do that at any point during the process. After you've come up with ideas, we need to figure out which one of these ideas are actually going to work and are going to be the best ideas in order to pursue those and determining what our final design will be. So we're using a lot of tools in order to make those decisions. We'll be doing some engineering analysis. You could be looking at some surveys. There's different ways that we can make decisions and helpful tools that we can use, and we want to try to achieve those goals that we've set and make sure we're not breaking any of our constraints. And then we can, once we have our final design selected, we can go through the process of actually sizing it properly, making sure that we've kind of tweaked and considered all the different loadings and different uses and different ways that it'll be used in the application. So the user could have a lot of different ways that they could be putting loads on it, or power requirements and things like that. So we may need to prototype it. We'll have to make some justifications along the way on why we made decisions, and we can then make sure that we are implementing it properly before we put it out to the user. So, and along the way we can update our specs again at any point. So that's kind of a rough overview of our engineering design process that we'll be going through.